So this is chapter 7, problem 6. This is the one where you have a knot and you have 3 ropes. So you have one person pulling with a force of tension in the positive x direction of 20 newtons. You have number 2 is 40 newtons pulling at 53 degrees above the negative x axis. And then you have force of tension 3, which is this person pulling in an unknown direction, unknown tension. And what we're supposed to do is figure out what force this person has to pull at and in what direction to keep this knot from not moving. So what I do is, again, I figure out the components. So here is force of tension 2. I move it over here, right? So here it is. And it's force of tension 2 is 40 newtons. There's Ft2 in the y and Ft2 in the x. I do the sine of 53 and the cosine of 53. You guys all know how to do this. And I figure out Ft2y. And I figure out Ft2x. So I got the 2 components, right? Then I go down here, I drew another picture. So I took the Ft2x, which I figured out over here, and I put that here. And I did Ft2y, and I put that there. And I labeled them. Ft1, I don't have to figure out the components because it is in the x direction. And then this Ft3 is comprised of an Ft3 in the y and an Ft3 in the x, right? So then what I do over here is I sum the forces in the y direction, because this is an equilibrium problem. They just want to know what I need to do here to make this thing stay in one spot, where the forces in the x and the forces in the y direction are all equal to each other. So what I do is I do the stuff in the y first. So I have Ft2 in the y plus Ft3 in the y. And if you look over here, there's only 2 forces when I break them up in their components in the y. We have this piece and we have this piece. Now, we know one of those pieces is 31.95 newtons. It's going up, so I call it positive. This Ft3y obviously has to be negative 31.95 newtons to keep this thing at a state of equilibrium in the y direction. Then I go down here in the x direction. And in the x, I have Ft1, which is this initial, if you look up here, it's this initial force of that first person. And then back down here, so I have Ft1, I have plus Ft2 in the x and Ft3 in the x. Now, if you look over here, here's Ft2 in the x, here's Ft3 in the x. We do not know this one. Once I do all the math, I've called to the right positive, I called to the left negative, and I just kind of estimated here. I didn't know what this was going to be, like what direction, but I guessed properly. I was just thinking it was going to be a little bit in this direction. If you look at the first picture, you'll see I just kind of guessed that it was over here. Just because looking at these forces, I kind of assumed that it had to be over here just a tiny bit. So I get Ft3 in the x as 4.1 newtons. That's what I get for that piece. Now, if you look, I got for Fty at 31.95, and then for F in the x, I got 4.1. So I just redrew this, and I put the x and the y components. And then, as you see, I used tangent of theta, and I figured out this angle, and that's 7.3 degrees, and I use it with these 2 signs. And then I used a squared plus b squared equals c squared, and when I did that, I figured out the hypotenuse of this triangle, because this is, if you look over here, you'll see that this is a 90-degree angle, and so it's pretty easy to figure that out. Now, so for this, I got the tangent of this angle because I had 2 sides, and then once I had those 2 sides, I was able to then do a squared plus b squared is c squared, and I got Ft3 is 32.21 newtons. So the answer is Ft3 is 32.21 newtons at 82.7 degrees below the positive x-axis, because I figured out what theta was. I just subtracted that from 90 and I got 82.7.